This video will cover the third page of notes for the topic of exponential functions. So the third page is going to be about actually solving exponential equations. Basically what we want to do is we want to make sure we can get the same base, and if we have the same base, then we can say the exponents are equal to each other. So that's what we want to do. So let's take a look at example number 3, part A. If we see that we have 1/3 to the x power, and then that's equal to 81, we need to get them to have the same base. So what I do know is I can change this 1/3 into a base of 3 because I know 3 to the -1 power causes this to be the reciprocal, which is 1/3. So that's where I'm getting this 3 to the -1, and then I still have it to the power of x. Using this particular rule about exponents, I'm going to multiply my two exponents, meaning if you have power to the power, you multiply those two exponents, and that's how I get 3 to the -x. So the question is, how can I change 81 so that it has a base of 3? We know that 9 times 9 is 81, and each of those 9s have 3 times 3. We can see how I'm getting my 3 to the 4th power. So now that I have the same base, then I know my exponents are equal to each other. So once we have that, then we can say that -x is equal to 4, and therefore x is equal to a -4. And again, we can probably put this in a calculator, put 1/3 like this in our calculator, and then make it to the power of -4, and we should see that that's going to give us 81. Now let's talk about part B. Notice I have 2 over here, and over here I have an 8, but we do know that 2 cubed is 8, and so that's where I'm changing this guy right here. And now that we have almost the same bases, remember I have a power to the power, so I need to multiply them. I just want to remind you that we want to make sure that we do the distributive property here when we are multiplying. And then that's how we're going to get that I have 2 to the exponent of x plus 4, and over here I have 2 to the exponent of 3x minus 18, because remember we did the distributive property. Now that the bases are the same, then I can say the exponents are equal to each other, and then from here it's linear, and you can go on ahead and solve from here. And you can find that your solution set will be the number 11. For example 4, our job is to solve exponential equations again. The problem we have here is that there's no way I can get the same base since we're actually looking for the base. So what I did for part A is I know I have b to the 2/3, and we learned that if we have a base that has an exponent that is a fraction, then we can rewrite that as the nth root of b to the m, or the nth root of b and then everything to the m power. So either one will work. So you notice that I've put in b to the 2/3 to be the cube root of b squared. And now we have a radical equation that we need to solve, which was covered in the last unit. So now I'm going to get the cube of both sides. Remember, I put one set of parentheses on the left, one set of parentheses on the right, and I'm going to cube both sides, and that's going to give me b squared is equal to 64. Then I'm going to take the square root of both sides. Don't forget you're going to do plus or minus. And so we actually find that b is equal to either plus or minus 8. But because the base has to be a positive number, we're only going to use b is equal to a positive 8. Down here at the bottom, a different way that you can solve this is by getting my exponents to multiply to 1. So if I had 2/3, then I'm going to multiply it by its reciprocal, which is 3/2, and that's going to give me b to the 1 power. But if I put this to the power of 3/2, then on the other side I also have to put it to the power of 3/2. And then we have to interpret that. That means the square root of 4 cubed. And then you have to decide, do I know 4 cubed or I can go find the square root of 4 and then cube it. Either one will work. So if you know 4 cubed is 64, then you're looking for the square root of 64. If you don't, you find the square root of 4, which is 2, and then we're going to cube it, and either way you do it, you're going to find that the base is equal to 8. Finally, let's practice that technique over here for part B. So what we're going to do, we have b to the 4/3, so I am going to put a set of parentheses, one on the left and one on the right, and then I'm going to put it to the power of its reciprocal. So 4/3 is going to have the reciprocal of 3/4, so I'm going to put the power of 3/4 on the left and the power of 3/4 on the right. What we do know is 4/3 times 3/4 is equal to 1, so I have b to the 1 power, and then I'm rewriting 3/4 as the 4th root of 81 cubed. And again, I don't know what 81 cubed is, but I do know the 4th root of 81 is 3. So now I just need to figure out 3 cubed, and that's 27. And that concludes this video.